The last topic that we usually cover on our semester midterm is usually going to be some trig, right? It's usually right around the end of the not school year, but the end of the calendar year. We get into some trig, maybe some unit circle, and then we send you off for 2 weeks and you get to relax, right? Unless you have that midterm that's after winter break, which I always hated. We used to have that in my school. And oh man, I felt so bad for the kids coming back from break and then had to take an exam. Like, it was tough. But this is the last topic we're going to cover on this one. So I have trigonometry. So find the period, amplitude, and phase shift for g of x. So let's give a g of x that's going to have all three of those. So let's do a negative 1/3. Let's do sine of x. So sine of 2x plus pi right there. And then, yeah, I don't really need that extra one. That's kind of weird. Okay, so negative 1/3 sine of 2x plus pi. Now, again, if you remember at the beginning of this video, I talked about transformations, right? It's the same thing, guys, happening over here. All right, now let's go and look at our transformation. So f of x equals a times times the sine of b times x minus c plus d. This is the exact same thing I gave to you at the beginning of this video, except I used like f of x or g of x in that case. But again, a and d are outside transformations. B and c are inside transformations. Now, when we're talking about amplitude, period, and phase shift, let's go over it. The amplitude is simply just going to be the absolute value of a. The period, and that's going to be how the amplitude again is the half distance from the max and the min of your vertical points on your graph. The period is going to be how long it takes the graph to repeat itself. So therefore, that's going to be 2 pi divided by b. And our phase shift is going to be how we're going to be shifting left or right, okay? So our phase shift is going to be phase shift is going to be left or right. We could have our starting point from on there. Because yeah, phase shift, okay. Okay, and that's going to be your horizontal shift. So let's go and identify how to find the amplitude. Amplitude, absolute value of a. Well, my a in this case is a negative 1/3. So negative 1/3, and that equals a 1/3. For my period, 2 pi divided by b. B is what we're multiplying by x. Now again, notice this is not in that format, right? So what you should do is when you have a b and a c is make sure you factor it out. So when I factor out a 2, I'm going to be left with an x plus a pi halves, right? Because when you multiply that out, you're going to get that original answer. So my period is going to be a 2 pi divided by 2, which is just going to be a pi. And then my phase shift is how are we shifting left or right? Well, you can see since it's plus pi halves, we're going to be shifting pi halves to the left. And there we go, ladies and gentlemen. That's how you identify your period, amplitude, and phase shift. And this is going to be the exact same if you're dealing with sine as well as cosine. But you do start having some changes once you get into tangent because there's no amplitude. And the period is pi compared to 2 pi. So make sure you review all those graphs as well. All right, last one, unit circle. Convert the angle from degrees to radians and then evaluate for tangent. So let's do one that's fairly basic here. Let's do 120 degrees. Okay, so how do you convert a degree to a radian? Now, I think it's really important that the more trig we do, the more familiar you are with radians. But sometimes converting is something we need to do. So all you're simply going to do is multiply it by pi over 180. Now I simply have 120 degrees times pi all over 180 degrees. Now I can just kind of simplify and say, what is the largest number I can divide in my top and my bottom? And I'm thinking 60. 60 goes in there 2 times. So it's 2 pi divided by 3. And again, your degrees are going to divide out. So therefore, that's a 2 pi over 3. Now, part 2 of the question says, can you evaluate for 2 pi over 3? All right. And evaluate is basically going to be look at the unit circle and the tangent of an angle on the unit circle is going to be the y coordinate over the x coordinate. Now, thankfully, 2 pi over 3 is on the unit circle. So or the point, there's a point on the unit circle at 2 pi over 3. So I just need to figure out what those coordinates are. So let's do a quick little review of how to graph 2 pi over 3 on the unit circle. Remember, we're always going in standard form. So we're going to start on the positive x-axis and we're going to rotate counterclockwise. We know halfway around the circle, ladies and gentlemen, is going to be pi. So therefore, we could break that up into thirds, and we're going to say 1/3, 2/3. So we're going to go to this point right over here. Now, hopefully, if you have the unit circle memorized, you know, not the unit circle, the first quadrant of the unit circle memorized, you know that this first point is going to be 1/2, comma, square root of 3 over 2. And this point and this point are direct reflections of each other across the y-axis. So therefore, this coordinate point is just going to be a negative x coordinate, and the y coordinate is going to remain the same. So I have a negative 1/2 over a square root of 3 over 2. So now to evaluate the tangent, that's going to be my y over x. So all I'm simply going to do is take a square root of 3 over 2 divided by a negative 1/2. Now my 2's will divide out, and I'm just going to be left with a negative square root of 3.